Back in the late 1980s, the whole dream of artificial intelligence, it wasn't just on pause, it felt totally dead. The hype train had completely derailed, all the funding vanished, and the entire field was stuck in what everyone called the AI winter. But right there in the ashes of that failure, a totally new kind of AI was about to be born. One that would, kind of quietly at first, and then all at once, change absolutely everything. Okay, let's really get into this, because it's an amazing story of resilience and, well, total reinvention. We're going to see how a huge shift in thinking took AI out of these dusty labs and put it right into our daily lives. So, how on earth did a few researchers, armed with a brand new way of thinking about probability, turn this billion-dollar flop into the very foundation of our modern world? To really get the comeback, you have to first appreciate just how big the collapse was. The late 80s and early 90s were a brutal, brutal time for AI. The whole billion-dollar industry built around these expert systems was starting to completely fall apart, and it was taking the reputation of the entire field down with it. It got so bad that the term AI itself became toxic. Seriously. Researchers would go out of their way not to use it. They were terrified it would make them sound like some wild-eyed dreamer with broken promises, which made getting funding next to impossible. The stigma was absolutely real. So the big promise of that first wave was something called expert systems. The idea was pretty cool. You'd capture all the knowledge of a human expert, like a doctor, into a bunch of computer rules to automate really complex stuff. But the reality? Oh, it was a total nightmare. They cost a fortune to build and maintain, and even worse, they were incredibly brittle. Like an expert system for medicine might know that a cough plus a fever equals the flu. But what happens if you tell it the patient has a cough, a fever, and a broken leg? The system, having zero common sense, might come up with something completely ridiculous just because that exact mix of symptoms wasn't in its super rigid rulebook. So here's the crucial thing. The problem wasn't just the software. The whole ecosystem was built on a shaky foundation. The special computers you needed to run AI, these things called Lisp machines, they cost an absolute fortune. We're talking up to $150,000 in 1980s money. And at the same time, regular old workstations from companies like Sun Microsystems were getting powerful enough and cheap enough to do the job just fine. So the specialized hardware market just vanished. And with the AI winter setting in, the funding just dried up. The dream was officially on ice. But while all that was falling apart on the surface, a really radical shift was happening in the background. A new generation of researchers started to realize that the old approach was just a dead end. They started asking, what if instead of trying to teach a machine a million strict rules, you could teach it to think in terms of likelihoods? So this is the old way, what we call symbolic AI. You try to write down human knowledge as explicit rules. If this, then that. The problem, as we just saw, is that the real world is messy. What if the cat's tail is hidden behind a chair? What if its ears are folded back? The system just breaks. And this is the paradigm shift. Thanks to pioneers like Judea Pearl and his work on Bayesian Networks, the whole approach just flipped. Instead of demanding absolute certainty, the new systems would calculate probabilities. They look at all the evidence and say, based on what I see, I'm about 85% sure this is a cat. This approach is flexible, it can handle uncertainty, and, this is the big one, it can actually learn from new data. So this new way of probabilistic thinking didn't immediately give us a walking, talking robot. Nope. Its first massively successful application was something way more practical, the spam filter. By looking at thousands and thousands of emails, the system could figure out that an email with the word Viagra in it had, say, a 99% probability of being junk, while an email from your mom had a 0.01% chance. It was a pretty quiet victory, but it proved this new approach really truly worked. So this new AI was quietly proving itself in the real world, but it was about to have a massive coming out party on the world stage. We're talking a showdown that would grab the entire planet's attention. And that showdown was over a chessboard. In 1996, the world champion Garry Kasparov, arguably the greatest player of all time, faced off against IBM's supercomputer, Deep Blue. Now, Kasparov won that match, but the machine, it managed to win the very first game. That was a shock that just sent ripples across the world. So, of course, the very next year, 1997, they had a rematch. And this time, Deep Blue won. A machine was now officially the best chess player on Earth. So how did it do it? Well, it was raw, brute force computation. Deep Blue could evaluate an absolutely astonishing 200 million chess positions every single second. It didn't understand the beauty or the poetry of the game like Kasparov did. It just saw deeper into every possible future of the game than any human brain ever could. And here's the really crucial takeaway from all this. The Kasparov match completely changed the goal of AI. It wasn't about perfectly simulating a human mind anymore. It was about leveraging the things a computer is uniquely good at. Its incredible speed, its perfect memory, its tireless ability to just calculate, to solve really complex problems. It was a massive wake-up call that a new kind of intelligence was here. But even with these powerful new algorithms and supercomputers, there was still one ingredient missing. One thing that was about to pour gasoline on the fire and really launch the modern AI era: data. And it was about to arrive in a tidal wave you just can't imagine. By 1998, the World Wide Web had just exploded. There were something like 150 million pages online. That created this huge public library of all of human knowledge, connection, and information. And for this new data-hungry probabilistic AI, this wasn't just a network, it was pure fuel. And this is where a tiny little search engine startup called Google had a genius idea. Their algorithm, PageRank, didn't just look at the words on a page. It looked at the structure of the web itself. It treated every link from one page to another as a kind of vote. But, and this is the key, it didn't just count the votes, it weighed them. A link from a really important, highly ranked page was worth way, way more than a link from some obscure blog. And the difference was just night and day. I mean, look at this. On the left, a search for university using this PageRank idea gives you exactly what you'd want: Stanford, Indiana, Minnesota. But on the right, the biggest search engine at the time, Alta Vista, it just gives you this jumbled, almost random list. By understanding the web's structure, Google could understand importance and relevance in a way nobody else could. So, with these brand new algorithms and a whole universe of data, AI was finally ready. It was ready to break out of the digital world and start moving around in the physical one. And this new AI started popping up everywhere. But its most dramatic test came from DARPA, the military's crazy research agency. They created something called the Grand Challenge, a race for self-driving cars across the Mojave Desert. The first race, in 2004, was a complete disaster. Not one single car finished. The best one only made it about 7 miles. But just 1 year later, in 2005, 5 vehicles successfully completed the entire 132-mile course. The progress was just explosive. And here's how it all connects back to our main theme. How did those cars do it? Well, they used the exact same core idea: probabilistic methods. Instead of having some rigid rule for what a rock looks like, their sensors gathered data to calculate the probability that something in their path was an obstacle they needed to drive around. It was the new AI, out on the open road. So, by the mid-2000s, the comeback was complete. The long, cold AI winter was definitively over, and a brand new spring had begun. All 3 of the critical pillars were finally in place. We had the probabilistic algorithms to deal with an uncertain world. We had the unbelievable computing power that machines like Deep Blue had shown off. And, thanks to the web, we had an endless river of data to learn from. The stage was officially set for the next revolution. But for all this incredible progress, there were still some huge challenges. AI was amazing at chess and ranking web pages, but it was still profoundly bad at things that we humans find totally effortless, like recognizing a friend's face in a photo, or just understanding what someone is saying. To solve that, researchers would need to go even deeper. And well, that's a story for our next explainer.